This arrived on Friday, and at first I thought it was empty because you can't feel anything in it, but there were two tiny things enclosed, and they are these. As you can see, they are very small. Believe it or not, these are 30-watt audio amplifiers. They're class D, and that's what enables them to handle so much power. But running at 24 volts, each one of these is a 30-watt mono amplifier, which seems astonishing. I just don't see it happening. But that's the claim. So we're going to see if that's the reality. So if you take a closer look and turn them over, the signaling scheme is very straightforward. Speaker, plus and minus, power and ground, the input signal, and a chip select signal. I'll get it hooked up and see what it does. This is a surround sound speaker from a TV audio system. It's 8 ohms and it says it's 15 watts. We'll see how we get on this one, and if it's still sounding like this tiny little thing has got more juice to offer at 15 watts, we'll go up a speaker. Well, we're hooked up. This is my, I call it my lab power supply. There's a laptop power brick in here and this thing from eBay which can limit current and voltage, which is useful. Got the chip itself, which is wired to everything. The music source is an old Android phone playing some YouTube copyright free music. This is the chip select pin. I don't know what to do with it, so I'll see what happens. It says it works from 8 volts to 24 volts, so we'll see what happens. It's currently on 4 volts. I'll start the music. It's going in this headphone adapter here. Nothing. Let's just turn the voltage up slowly. So that's 6 volts. Oh, there we go. So it's actually on 7 volts. So far, so good. So already it's ridiculous, and by the way, the chip select doesn't seem to be needed, it's just floating. Actually, I'll just take it high and low and see what happens. Yeah, low stops it. Not low means it's running. So we don't really need chip select to wire it to VCC, or just leave it loose. Okay, so it's quite loud, nowhere near 30 watts I should imagine. This is only a 15 watt speaker anyway, but it's distorting, but that could be because the voltage supply is very low. So let's increase the voltage. Let's go to 12 and a bit volts, see what that does. So the clipping that was apparent at 7 volts has gone away. 0.2 of a watt when it's running. Actually, it's taking 0.1 of a watt, doing nothing. The hum is still there. That's probably coming from the power supply. Well, that's very impressive. It's not hi-fi. The power supply won't go above 18 because it's being fed by a 19.5 volt laptop battery. So I've disconnected the bench power supply, which is sending AC hum. We can now see that the hum is completely gone. Not a hint. And now we'll play some music again. I've put the bench power supply back in circuit. I can measure the current from it. I've got it supplying the voltage through in series with a lead acid battery, and I'm measuring the combined voltage over there, so it's now at 15 volts. So I can work out the power by timesing this voltage here by this current here, and I can exceed the 18 volt maximum from the power supply by combining it with the lead acid. So I could actually go to I could exceed the limits of the amplifier if I wanted to, which of course I don't. And we're ignoring the AC hum because we know that it comes from the bench power supply, and therefore it's not a factor. So we've got 15 volts. Let's go up to 24 and just see where that takes us. So I'm watching this over here. No increase in voltage, interestingly. So that's 23.6. Now we just go up on the... Right, so that's too loud for the neighbours to tolerate for very long. This thing here is driving this thing here. I mean, leave it at that ain't gonna happen, is it, darling? Okay, let's fire this thing up again. Okay, again, I don't want to upset the neighbours, but that was peaking at 0.7 of a watt. Actually, that's wrong. The current was peaking at around 80-90 milliamps. Call it 100 milliamps, which means the peak power would have been 2.3 watts, which doesn't square with the volume, which was deafening for me. So it could be that the current transients are much higher than that. And if that's the case, I don't know how to measure them. So what I am prepared to say is that this tiny little amplifier can make more noise than I can tolerate long term. Just warm. At this point I'm going to stop. I'm going to hold myself in amazement. That is impressive, really impressive. So I'm going to press ahead and get the bike audio system running. Well, there it is. Those tiny little chips really do the business. Huge amounts of sound, almost no heat, and a tiny space, and £2.50 odd for the pleasure. So I'll press on, as I say, and implement a sound system for the bike, which involves an alarm, replacement of the bell, and some other bits and pieces, which will feature in a future video. I hope you enjoyed the video. And if you did, you might want to subscribe, like, comment, share. Anyway, thanks for watching.